Inspired by Mechazilla, a robotic replica of Godzilla that fought with the original, in the 1974 film Godzilla vs. Mechagodzilla, Elon Musk created the Mechazilla, a new launch tower that serves as an autonomous purpose in rocket launch operations for SpaceX. But people in the space community have been talking about if this Mechazilla catcher and the Super Heavy rocket would work without defects, even if the catching arms operation procedure appears to be top-notch, evidence from simulation videos. Keep watching as we will expose more operations of the Mechazilla catcher and discuss what makes it crazier than we all thought. Consider this: when a full-stacked 394-foot-tall Starship is launched into space at a certain height, the incredibly heavy booster separates from the second stage Starship and drives itself back to Earth. Of course, it will not descend on the ground, rather on both arms of the Mechazilla catcher. Elon Musk tried this method in the simulation program and it worked, but the concern is, will it work in reality? Let's all watch and see. Consider the landing procedure of a commercial plane from the sky to the ground. Recall that the plane lands owing to the impact of gravitational force and its tires scrape the ground surface at a great force while exerting friction. However, in the case of the Super Heavy rocket, during landing, it lowers itself in between the arms of the Mechazilla catcher and slowly lands its fins on the Mechazilla arm's frame, before it slowly moves it down to the launch pad without exerting a powerful force that will cause impact on the launch tower or destroying it. This same scenario would have caused destructive impact if it was in the case of commercial airplane tires hitting the surface of the ground. This is one of the reasons why we say that SpaceX built the tower to operate impeccably, yet crazy. But what's crazier? Do you understand why the landing operation of the Mechazilla catcher is feasible? Well, let me explain this. If you're an engineer, you'll know that the Super Heavy rocket can't slowly lower itself on the Mechazilla arms unless it has eyes. The eyes see the two arms, send signals, which calculates the distance required to accurately suspend itself and place its fins on the arm, and at the same time regulate the thrust or rate of propulsion required to slow down the 230-foot-tall Super Heavy. The eyes we're talking about here are sensors. When the Super Heavy lands on the Mechazilla catching arms, the arms will move the rocket downward as well. The entire procedure serves as a way of suspension as well as reducing the rocket's downward thrust. This operation is what makes the Mechazilla catcher crazier than we thought. SpaceX engineers performed extensive mathematical analysis to make the process conceivable, and it is currently being built into reality. We sincerely thank the source that provided this intelligence to SpaceX engineers, because the operations keep the whole space community engaged, and many people begin developing interest in practically all SpaceX constructions. Let's briefly discuss about horizontal and vertical construction of rockets and why the Mechazilla launch tower will be advantageous for constructing rocket structures in the space industry. Strong-back rockets are those that are transported to the launch pad in a horizontal orientation, since it is easier to manufacture and store a rocket horizontally than vertically, and then flipped it up to vertical position when it's time for testing. The strong-back prevents the rocket from folding in half during the process, and it's commonly known as a claw. Rockets that do not require strongbacks are often constructed vertically and hold out to the pad vertically. This is in the case of the Starship. As a result, they require less support in general, and while the connections give some stability, the rocket isn't as reliant on them. The ground support equipment GSE arms mission with the launch tower at Boca Chica serves several functions, like providing propellants, electricity, and other necessities to the Starship's second stage. While almost every other rocket is intended to be stacked in a hangar before being transferred to the launch pad in its final configuration, Starship and Super Heavy are designed to be stacked at the launch tower. When stacking a Starship onto a Super Heavy, at least 3 connections on the booster must match up with the slots in the back of the Starship. The chopsticks catching the lifting arms will have a pretty solid grasp on the second stage, attached to the chopsticks via 4 stiff mounting points, but will be missing the GSE arm. Super Heavy would only be supported at the base, and if winds were to pick up, the top of the Super Heavy would shake in the breeze, making stacking impossible until the wind dies down. SpaceX engineers have already successfully stacked a Starship onto a Super Heavy using a crane and no GSE arm for stability, but this was done on a day with low winds or optimum circumstances, whereas SpaceX intends to be able to stack and launch Starships in a wide range of weather conditions. They can, however, use the GSE arm to capture the top of the Super Heavy and keep it stationary while the catching arms stacks the Starship. Another small distinction appears to be that other launch tower connections brace and connect to the same stage of the rocket. Part of the reason the Saturn V has so many connectors is because it has multiple stages and connectors for each tank. The single GSE arm will brace the very top of Super Heavy, the first stage, while the GSE fast disconnect system on its top will feed fluids and electricity to Starship, the second stage. Another distinguishing feature of the GSE arm is that it is hooked to the back of the tower and extends all the way to connect to the Starship and Super Heavy. Every other tower, by contrast, employs arms that are on the side of the tower facing the rocket or just to the side to allow them to fold out of the way before launch. This is because, unlike any other launch tower, the GSE arm for Starship Super Heavy must move out of the way of the huge catching arms carriage, which can travel up and down the tower along tracks. Because the catching arms are out of the way, they can go all the way down to just above the pad to lift the Starship off a transport, all the way to the top for when a Super Heavy is descending from the sky and the arms have to start moving down the tower to stay alongside the booster as they come together and grab the booster out of the sky, assuming everything works as planned. The Mechazilla will allow for the quick assembly of starships and boosters and render the possibility for the same starship to be launched numerous times each day. Turnaround times for launching starships might rival those of air travel, and that will drastically reduce global transit durations from days to minutes. It all comes down to the capturing mechanism, which is designed and believed to be able to catch a free-flying 100+ tons booster as well as the upper stage as it returns to Earth in real time. It'll be kinda difficult in a way because of the fact that the hull of the returning starship will be unable to withstand any compressive load without crumpling. Using chopsticks to pick a butterfly out of the air without crushing the delicate body is a nice comparison. Of course, a starship will not flutter around aimlessly, but accuracy is essential here, with the only permitted touch sites being the lifting points on the starship hull. When the Super Heavy gets in contact with the catching arm, there is essentially no relative motion between itself and the catch arms, and it will be a difficult scenario to get a perfect operation at the first trial, and all to the sight of this being attempted for the first time will be breathtaking. Elon patiently explained this for several decades, but no one has taken him seriously until now. Thousands of more Starship missions will be required to establish a self-sustaining human civilization on Mars, and more will be employed to mine asteroids, develop space colonies, and so on. Elon Musk aims to launch starships at the fastest rate possible from a variety of spaceport platforms throughout the world. There is also rocket transportation from one location on Earth to another in about 1 hour. There will also be thousands of airliners in the sky at any given moment. They will land, refuel, and then take off again. That's what Elon Musk is planning for the Starship rockets. The Mechazilla at Starbase is only a test model. They'd be erected on all of the spaceport platforms from which Starship operates. How best will you describe the operation of the Mechazilla catching arms? Be sure to check out your favorite SpaceX video here.